Hi everybody. So in this video, we're going to look at using sec, cosec, and cot to set up trigonometric identities and solve trigonometric equations. So in example 1, we need to simplify cosec x multiplied by the tan of x. And when you simplify expressions like this, the best idea is to write the terms using sine and cos. We know cosec x is 1 over sine x. And tan x is the same as sin x over cos x. So by writing it in this form, you can see we can simplify the sin x. This division will cancel with this multiplication. So what we're left with is 1 over cos x. And this is sec x. So you can see it's much easier to write it as sec x rather than what we have here. Do you want to try and simplify question B? Try and write tan x in terms of sine and cos, and then simplify where you can. Okay, so we have 1 over tan x, sine x over cos x, multiplied by cos x. You can see that these two will cancel, so we're left with 1 over sine x, which is cosec x. How did you get on with that? Do you want to try question C? So we have sine x plus cos x times cot x. And this is 1 over tan x. So we can write this as a division. And then we can simplify cos x over tan x. We'll have cos x divided by tan x. So sin x over cos x. And then we can write this as a multiplication. So cos x multiplied by cos over sine. And then you can see here we've got cos squared. So we'll have sin x plus cos squared x over sin x. So what do you think we need to do now? So now we've got two fractions with different denominators. We've got a 1 and a sin x, so we need a common denominator. We'll multiply this by sin x. So we'll have sin squared x over sin x plus cos squared x over that same denominator. Now we can put these two together. So sin squared x plus cos squared x over sin x. What do you think we can do with our numerator? So our numerator simplifies to make 1. So we have 1 over sin x, which we know is cosec x. Okay? So whenever we need to simplify terms like this, it's always a good idea to try and write them in terms of sine and cos. If we look at example 2, so now we need to solve this equation. We've got 3 sin x equals 2 cot x within the range of 0 to 360. Do you want to give this question a go? Think about how we can write this cot x. You can pause the video and come back when you're ready. Okay, so we've got 3 sin x will equal 2 cot x. And the cot x is 1 over tan x. So we can write this as cos over sine. And then we can move this sin x to the left-hand side. So we've got 3 sine squared x will equal 2 cos x. And then we can write this sine squared x in terms of cos squared using the Pythagorean identity. So we'll have 3 lots of 1 minus cos squared x will equal our right-hand side. We'll expand out this bracket. And then we just need to make this equal 0. So I'll move these two terms to the right-hand side. So we'll have 0 will be 3 cos squared x plus the 2 cos x minus a 3. And this won't factorize, so I can solve this on my calculator. If we go to home and we want equation, we want polynomial, and we're quadratic, we've got a coefficient of 3 for the cos squared term, 2 for the cos term, and negative 3 for the constant. So we have approximately cos x will equal 0.721, cos x will equal negative 1.387. Now, this solution is not valid. Why do you think this solution might not be valid? Well, it's not valid because the range of cos x is between negative 1 to positive 1. So we can cross this solution out. We need to focus on this one. So if cos x is equal to 0.721, we can take the arc cos of both sides. So x will equal the arc cos of 0.721. And we want this in degrees. And this works out to be approximately 43.9 degrees. But within the range of 0 to 360, we'll draw a cast diagram. We know we're looking at a positive, so we'll be in the first quadrant. And the other solution will be in this quadrant where cos is also positive. So we'll have 43.9 degrees here. So x will equal 43.9. And then within our range, we've got the 360 minus that 43.9, which is 316.1 degrees. Okay? Let's try one more question. So in example 3, we've got an exam style question. We need to prove this identity, and then we need to use this solution to solve this equation. Do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we'll begin by simplifying this left-hand side. Cot of x will be the cos of x divided by sine of x. And tan of x will be sine over cos. And we're dividing all of this by 1 over cos, which is the sec x. So the first thing I'm going to do is add these two fractions together. So we need a common denominator. So we'll multiply this fraction by cos x and this one by sine x. So we'll get cos squared x plus sine squared x over sine x cos x. And all of this will be divided by 1 over cos x. We know our numerator will simplify to make 1, and then we can multiply all of this by the cos x. So we'll have 1 over sine x cos x multiplied by cos x over 1. And then you can see that this one will cancel with this one. So what we're left with is 1 over sine x, which we know is cosec x. And that's what we were asked to show. So what this tells you, we can rewrite this left-hand side as cosec x equals 3. And this is 1 over sine x. We'll move the sine x to the right-hand side and the 3 to the left-hand side. So we get 1/3 is equal to sine x. And then if we take the arc sine of both sides, we'll get the arc sine of 1/3. And again, you can see that we're dealing with degrees, and we get approximately 19.5 degrees. To find the other solution, I'll sketch the cast diagram. We're dealing with a positive, and sine is positive in the first quadrant and in the second quadrant. So x will equal with 19.5 And for this one, we'll have 180 minus that 19.5. And we get 160.5 degrees. Well, I hope that's given you an idea on how we can use sec, cosec, and cot. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link below.